Okay, I'd like to finish up section 11.1 here. We're talking about sequences. And now here's the example that we had left off with right here. So let's see. Now, the way that I've got this defined is a recursively defined sequence. Okay, and all that means is that I got a sequence which is defined within the same sequence. Okay, so a sub 1 is 2. Now to get the next term, I'm going to take 1 divided by 3 minus the previous term. Okay, a sub n always has to be a number that is positive but less than or equal to 2 as well. Okay, so let's just list out the first couple of terms here. And I'd like to know, does this sequence, a sub n, converge or diverge? That's the question here. Let's see, a sub 1 is 2, right? So I got 2 there. Now a sub 2, that's defined to be 1 divided by 3 minus a sub 1. A sub 1 is 2, so 1 divided by 1 is 1. A sub 3 would be 1 divided by 3 minus a sub 2. A sub 2 is 1. So I got 1 divided by 3 minus 1 is 2, so 1/2 would be a sub 3. Okay, a sub 4 would be 1 divided by 3 minus a sub 3, or 1 divided by 3 minus 1/2. 3 minus 1/2 is 5/2. Okay, and I got 1 divided by 5/2. If I flip that, I get 2/5 then for a sub 4. Okay, a sub 5 would be where I take 1 divided by 3 minus a sub 4, that's 2/5. So then 3 minus 2/5 is, let's see, oops, I get 13/5 here. Okay, so I got 1 divided by 13/5. When I flip that, I get 5/13 for a sub 5, etc. Okay, so these are just what the first 5 terms look like. Now, I want to know, does this sequence, a sub n, converge or diverge? There's a couple of questions like this in the book, okay, where you got a recursively defined sequence. Well, the limit as n approaches infinity of a sub n, that is equal to the limit as n approaches infinity of a sub n plus 1, because, so if I were to list out the first 20 terms, all those terms are headed to the same spot. That wouldn't be any different from if I were to list out the first 21 terms. All those terms are headed to the same spot, right? So whatever that value is, we'll call that L. Okay? And so if I take the limit of each side of this equation here, the limit as n approaches infinity of a sub n plus 1, that's L, equals 1 divided by 3 minus the limit as n approaches infinity of a sub n, that's L. Okay, so I have the equation L equals 1 divided by 3 minus L. Okay, and if I solve this guy for L, multiply both sides of this by 3 minus L, and then distribute in the L. Okay, so I got 3L minus L squared equal 1. And let me get all the terms under the right. Okay, so L squared minus 3L plus 1 equals 0. That's not going to factor nicely for us. So I'd use the quadratic formula to solve for L. Okay, so let's see, I got the opposite of B, that's 3, plus or minus the square root of B squared, negative 3 squared is 9, minus 4 times A is 1, times C is 1, all over 2A, or 2 times 1 is 2. Okay, and I'm looking at 3 plus or minus root 5 all over 2 is the value of that limit. Okay, now this condition right here may seem like something easy to overlook, but it's actually very, very important. So the values of the sequence are always going to be numbers that are in between 0 and 2, including 2. we can see that from the terms that we have listed. And of course, I've got an infinite sequence, so I'm going to, I got the dot, dot, dot there. Well, let's see. So if I type this in here to the calculator, I got 3 plus the square root of 5 divided by 2. That number is bigger than 2, right? So I'm ignoring the positive case, the 3 plus the square root of 5 divided by 2, since that number is bigger than 2, okay? Now I got 3 minus the square root of 5 divided by 2. That's that guy. Okay, so because of this condition here, where all the terms have to be between 0 and 2, that means that the value of this sequence here is going to converge to 3 minus the square root of 5 divided by 2. Okay, so I say a sub n converges to 3 minus the square root of 5 divided by 2. Again, there's a couple problems like that in the book. Okay, there's not a lot, but there's some recursively defined sequences is what it's called there. Okay. Let's take a look at, here's a definition. It says that the sequence a sub n is called monotonic if its terms are increasing, so that is, the next term is always bigger than the previous one, or if its terms are decreasing, so the next term would be smaller than the previous one. Okay? Now, in the last example, this guy here, this is an example of a monotonic sequence because when I list out these terms, they're decreasing, right? So each term after the next is going to be smaller than the previous one. So 1 is smaller than 2, 1/2 is smaller than 1, 2/5 is smaller than 1/2, right, etc. Okay? So let's take a look at, I got 2 examples here. What if we had the sequence a sub n equals n squared divided by 2 to the n minus 1. Now that's a sequence that we had looked at previously in this section here. And I want to know, is that sequence monotonic? Okay. Well, let me just plug in some of the terms here. So if n is 1, I got a sub 1 is 1 divided by 2 minus 1 is 1. A sub 2 would be 2 squared is 4 divided by 2 squared is 4 minus 1 is 3, so 4/3. Okay, so 4/3 is bigger than 1, right? So if it were going to be monotonic, all the terms have to be increasing here, okay? Let's plug in 3 next. So a sub 3, that'd be 3 squared is 9 divided by 2 cubed, that's 8, minus 1 is 7. So I'm getting 9/7. Okay, so then the next question would be, is 9/7 bigger than 4/3? And the answer is no. Okay, because if I cross multiply here, 4 times 7 is 28, 3 times 9 is 27. What's the bigger number? 28 is bigger than 27, right? So 4/3 is going to be bigger than 9/7. So it does not increase, right? Like each term isn't going to be bigger than the previous one. So this is not monotonic, I'd say. Okay. What if we look at another sequence here? So how about what if we had let's see. So a sub n equals 3n divided by 1 plus n. Okay. Well, I'll list out the first couple of terms just to get an idea, you know, if number 1, if this is monotonic, and then number 2, is it decreasing or increasing? Okay. So a sub 1 will be 3 times 1 is 3 divided by 2, that's 3/2. A sub 2 would be 3 times 2 is 6 divided by 3 is 2. Okay, so I think that the terms might be increasing if it's monotonic. A sub 3 is 3 times 3 is 9, divided by 1 plus 3 is 4. Okay, 9/4 is bigger than 2. Okay, now rather than continuing, out these terms, I think that this is monotonically increasing. Okay, like each term after the previous one is going to be bigger. Okay, now I'll have to show that. Okay, so we have to show that a sub n plus 1 is going to be bigger than a sub n. And this is for all n that's greater than or equal to 1. There's 2 ways that we can do this. Okay, so the first way, I got to show that this inequality is true. Well, a sub n, that's 3n divided by 1 plus n. A sub n plus 1, if I replace n with an n plus 1, everywhere I see an n, there, I got 3 times n plus 1 divided by 1 plus n plus 1. So is this true? That's the question. Well, let me go ahead and cross multiply this. So I got n plus 2 times 3n, and then 3 times n plus 1 times another n plus 1 would be on the right. Okay, so then if I distribute 3n, I get 3n squared plus 6n on the left. On the right, if I FOIL this out and then distribute the 3, I'll have 3n squared plus 6n plus 3. Okay, and let's see, if I cancel, here's a 3n squared and a 6n on both sides, right, so I can cancel those, and I'm left with 0 is less than 3. Well, that's a true statement, right? 3 is bigger than 0. So now, if I were to prove this, I would start with this guy here. I'd say 3 is bigger than 0, and then that leads to this line. So 3n squared plus 6n is less than 3n squared plus 6n plus 3, and that leads to this sign. So I've got arrows on both ends here. So what that means is that you can read it, left to right or right to left, right? So I've got if and only if statements here. Okay, so if I were to write up a proof, I would start with 0 is less than 3. That's true, right? And then I would eventually get to this guy here, which is what I had to show. Okay, that's one way to do this. Okay, now another way is I got to show that this sequence is increasing. Well, what if I had the function f of x equals 3x divided by 1 plus x? That's similar thing, right? Now, going back to Calc 1 here, if I take a derivative of 3x divided by 1 plus x, that'd be a quotient rule, right? So I got the bottom times the derivative of the top, that'd be 3, minus the top is 3x times the derivative of the bottom, that's 1, all over the bottom squared. So I'm looking at 3 plus 3x minus 3x. The 3x's are gone. And so I got 3 divided by 1 plus x squared. Okay, so I need to know when that is positive. Well, 3 divided by 1 plus x squared, that's going to be always positive, no matter what x is, right? Because I'm squaring the denominator, and 3 is a positive number, right? So I'll always have a positive value here if I plug any number into f prime. So what that means is that f, the original function, would be increasing everywhere, okay? Except for when x is -1, which by the way I don't care about, because x can't be -1 anyway, right? Because I'm only looking at positive x values here, so because f is increasing everywhere, then I would say that it's monotonic, or I could also say that it's monotonically increasing. Would be another way to say it. Okay, so there's a couple of questions like this kind of at the end of the section there where they give you a sequence and they want to know, is it monotonic? Okay. And if it is, you're going to say it's monotonically increasing or monotonically decreasing. Okay. And there's two ways that you can prove your answer. Okay. So this is one way. And here's another way that you can prove your answer. Now, by the way, I kind of prefer this way because in this example, like, so it conveniently worked out that we got to the end here where we had 3 is greater than 0. Now, it's not always going to work out nicely like that, you know. So I would say that in general, you know, why don't you call the sequence a function and then take the derivative, and we're using the first derivative test to see if we're increasing or decreasing, you know, to give our answer. Okay. All right, so that's it with section 11.1. Here's the homework, and we'll start in on 11.2 in the next video.